Hello viewers, I've come again with the same lesson of class 10 polynomials, and today I'll be solving exercise 2.2. So please subscribe to my channel for more updates. Now let's move on to our exercise. So let's start doing exercise 2.2. So question number 1. Find the zeros of the following quadratic polynomials and verify the relationship between the zeros and the coefficients. Okay, first we'll find out the zeros of this quadratic polynomial and we'll verify the relation between the zeros and the coefficients. We'll find out the zeros and afterwards we'll verify the relation between them. Okay, so this is called a quadratic polynomial. As I've said in my exercise 2.1, in my video in exercise 2.1 about quadratic, cubic and linear polynomial, where the highest degree of x is 2, it is called quadratic polynomial. Now we'll write here, we have x square minus 2x minus 8. Okay, this we can break and write like x square minus 8 we can write as 4 minus 2 we can write as 4 minus 2. 4 2s are 8 and 4 minus 2 is 2. X minus 8. Okay. Now x square minus 4x plus 2x minus 8 equals to x. We'll take common between these two. Oh, sorry. Here I have not written x. X minus 4 plus 2 common between these two, x minus 4. So we have x plus 2 and x minus 4. So what is this x plus 2 and x plus 4? This quadratic polynomial will be 0 when x plus 2 equals to 0, x minus 4 equals to 0, or x equals to minus 2 and x equals to 4. So in this, for this we will find that this quadratic polynomial will be 0. Now you see the value of this polynomial will be right x square minus 2x minus 8 is 0 when this 2 will write x plus 2 equals to 0 or x equals to minus x minus 4 equals to 0, or x equals to, we can write minus 2 and x equals to 4. So this will be 0 when x equals to minus 2 or x equals to 4. So these are the zeros of this polynomial, quadratic polynomial. So we'll write the zeros of x square minus 2x minus 8 are this minus 2 and minus 4, minus 2 and 4. These two are the zeros. Okay, now we'll find the relationship between zeros and the coefficients. So what are the zeros? Sum of zeros equals to, we'll sum up these two, minus 2 plus 4 equals to 2. So what is the sum of zeros? Sum of zeros equals to minus of coefficient of x by coefficient of x square. Okay, so what is coefficient of x? Along with this is called the coefficient of x, and this will be called the coefficient of x square. Okay, along with this variables. So what is minus of, what is coefficient of x? It is minus 2 this minus is this one, and coefficient of x square is 1. If there is nothing, there will be 1. So it is minus minus plus 2. 2 ones are 2. So you see the sum of zeros equals to minus of coefficient of x by coefficient of x square. Hence it is same, it is verified. Now we will do in the same way for question number 1, number 2. The next expression, quadratic expression, is 4s square minus 4s plus 1. So 4 we have, you write as we have this expression, you write which is given above, 4s square minus 4s plus 1. So this we can write as, we will break and write as 2 plus 2. 2 2s are 4 and 2 plus 2 is 4s plus 1 equals to 4s square minus 2s again minus 2s plus 1 equals to, we'll take 2s common in between these two, and what remains 2s minus 1, and here 1 2s minus 1. So we have 2s minus 1 and 2s minus 1. So this expression will be 0 if 2s minus 1 equals to 0, and for this also 2s minus 1 equals to 0. So the expression 4s square minus 4s plus 1 is 0 when this one, first we'll write 2s minus 1 equals to 0, or 2s, we'll write as, if it is this 2s minus 1 is 0, then we'll have s equals to 1 by 2, or 2s minus 1 equals to 0, same thing, s equals to 1 by 2. So now we will verify the relationship between zeros and the coefficients. So in both cases we have s equals to 1 by 2, s equals to 1 by 2. First we'll take the sum of zeros, sum of zeros. We can do it in this way also, equals to minus of coefficient of x by coefficient of x square. So what is the sum of zeros? See here, 1 by 2 minus 1 by 2, and it is coefficient of x is, or sum of zeros, it is plus, and coefficient of x is, what is this? Coefficient of s. So what is the coefficient of s? It is minus 4, and we have one minus here, minus, okay, and the coefficient of s square is 4. So here half plus half is 1 equals to minus minus plus 4 by 4, which is 1. So it is verified that the sum of zeros equals to the coefficient of s minus of coefficient of s by coefficient of s square. So now we will find out for this the product of zeros. So product of zeros is the constant term by the coefficient of s square. So product of zeros, half into half, 1 by 2 into 1 by 2. So what is the constant term? Constant term is 1, and the coefficient of s square is 4. So it is 1 by 2 to the 4. So now it is verified. See the relationship between 0 and the coefficient. Let's do question number 3. Number 3 is 6x square minus 3 minus 7x. So here see x square, x, and this is the constant term. So we will keep the constant term at the last. So we have 6x square minus 3 minus 7x, which we can write as 6x square minus 7x minus 3. Okay. Now see 6 3s are, we have to multiply this 2. 6 3s are 8. How much we will get? This 18. 6x square minus, right, 9 minus 2. 9 2s are 18. 9 minus 2, 7x. 6x square minus 9x minus and minus plus 2x minus 3. 6x square, here we are getting 3x is common. 2. 3 2s are 6. X minus 3 3s are 9. Plus 1 will get common in between these two. 2x minus 3. So we have 3x plus 1 and 2x minus 3. So the zeros will be the 3x plus 1 and 2x minus 3. In that case, this will become 0. Okay. The value of this will become 0 when this is 0. 6x square minus 3 minus 7x is 0 when 3x plus 1 equals to 0 or 2x minus 3 equals to 0, where x equals to minus 1 by 3 and here x equals to 3 by 2. So we'll write here x equals to minus 1 by 3 or x equals to 3 by 2. So now we'll verify these two terms. Sum of zeros equals to minus of coefficient of x by coefficient of x square. This two zeros is minus 1 by 3 and 3 by 2. Minus 1 by 3 plus 3 by 2 equals to minus of, what is the coefficient of x? It is minus 7. And coefficient of x square is 6. Equals to, and this 2. We'll take the LCM. 3 to the 6. 3 2s are 6. 2 into 1 2 plus 2 3 is 6. 3 3s are 9. This I've taught you in previous classes. Minus minus plus 7 by 6. So this is 9 minus 2, 7 by 6. So it is verified. Now we will do for the product of zeros. The denominator will be same. We will write out a constant term. Now see what is the constant term. Constant term is minus 3. And coefficient of x square is 6. And here 3 into 1, 3. 3 to the 6. Minus 3 by 6. 1 by 2. 1 by 2. So it is verified here. See, I have done here up to question number 3, and all of the method is same for all. So you can do for all other numbers in the same way. So we'll move on to question number 2 because you can solve the others in the same way. So question number 2 here. Find the quadratic polynomial each with the given numbers as the sum and product of its zeros respectively. Okay. So here we are given the sum and product of zeros. This is the sum and this is the product of zeros. So this is just the opposite from the previous question, question number 1. There we are given a quadratic polynomial and we have to find the sum and product of the zeros. We have to find the zeros. Here we are given sum and product of the zeros and we have to find the quadratic polynomial of this. So it is a quadratic polynomial, so we'll assume this as a quadratic polynomial. Ax square plus bx plus c. Why we have taken ax square? Because quadratic polynomial, in quadratic polynomial the highest degree of x is square. Okay, so we'll assume this as, let ax square plus bx plus c be the quadratic polynomial. Okay, and alpha and beta are the zeros. So here we are given the sum, so we'll write here sum of the zeros equals to 1 by 4, which is minus of coefficient of x by coefficient of x square. Okay, now you see what is minus of coefficient of x? Minus, minus, and coefficient of x is along with x, this is b, and coefficient of x square is a. So we get this minus b by a equals to 1 by 4. Now this is the sum. Now product of zeros. What is the product of zeros given here? It is minus 1. So what is the product of zeros? Constant term by the coefficient of x square. Which is, what is the constant term? It is c, and the coefficient of x square, it is a. So we got c by a equals to minus 1. So we got c by a as minus 1. First we'll write minus b by a equals to 1 by 4. C by a equals to minus 1. Okay. Minus b by a equals to 1 by 4. C by a equals to minus 1. So we got here two values of a, minus b by a, c by a, minus 1 by 1 you can write, which is same as minus 1. So here you see, you multiply here by 4. So as to make this two a equal denominators, into 4, which is minus 4 by 4. If you cut this 4, it remains minus 1. Okay. Now we got a as, see, a 4a 4, b as b is minus 1, b equals minus b equals to 1 means b equals to minus 1, and c equals to, what is c? 4, minus 4, c equals to minus 4. So we'll substitute a, b and c in this quadratic polynomial. So the required quadratic polynomial is, first we'll write this, ax square plus bx plus c, which is, what is a here? 4x square. What is b here? Minus 1x, and c is minus 4, which you can write as 4x square minus 1x. We can write it as minus x minus 4. So this is the required 4x square minus x minus 4 is the required quadratic polynomial of the sum and product of its zeros. Now we will do question number 2. Okay. So number 2 is root 2 and 1 by 3. This is the sum and this is the product. Okay. So in the same way we'll do like the previous one. Number 1, we'll assume ax square plus bx plus c as the quadratic polynomial. Okay. So let ax square plus bx plus c be the quadratic polynomial where alpha and beta are the zeros. Okay. So these are the zeros. So what is the sum and product of the zeros? Sum is this and product is this. So the sum of the zeros, these are the zeros. So we'll sum of this, we get as root 2, which is already given in the question. So what is the sum of zeros? It is the minus of coefficient of x. So it is minus of, what is coefficient of x? B, by coefficient of x square is a. So we got minus b by a. So minus b by a equals to root 2 by, you can write it as 1 because minus root 2 by 1 is also equals to root 2. Now we'll find the product of the zeros. So we got it as b root 2 minus root 2 and a is 1. So let's see what we'll get by the product. Product is 1 by 3 equals to, what is the formula for product? Constant term by the coefficient of x square. Okay. So c by the, what is the coefficient of x square? It is a. C by a. Now c by a equals to 1 by 3. So you see here we got b as minus root 2, a as 1, c as 1, a is again 3. So to make this a similar, either we will multiply here with 3 or we'll multiply here with 1. So we'll do here minus b by a equals to root 2 by 1 and c by a equals to 1 by 3. Okay, so to make this similar, what we will do here, if you multiply here with 1, it will remain the same, so we will multiply here with 3 so as to make the both this denominator same. Okay, this is our main motive, to make the denominator same. So here also we'll multiply by 3. So because if 3 root 2 and 3, if you'll cut this 3, you'll get this root 2, it will be the same. So now it becomes 3 root 2 and here 3. which is like b equals to minus 3 root 2, a is 3, a is 3 here, and c is 1. Now we got this a and this a similar. So now we got a as, what is a? 3. B as, what is b? B is this one, minus 3 root 2. We can shift this minus in the number. And c as, what is c? 1. Now you can put this in this quadratic polynomial and you'll get this answer, okay? A 3, b minus 3 root 2 and c 1. So the required quadratic polynomial is ax square plus bx plus c, which is, what is a here? 3, 3x square, what is b here? Minus 3 root 2 x plus, what is c here? 1. So this is the required quadratic polynomial. Now we will do question number 3, and in this way you can solve the other numbers also. I will do only up to question number 3. So number 3 is 0 and 5. In the same way like the previous above 2, we'll assume this as quadratic polynomial ax square plus bx plus c, where this is the sum and this is the product, okay? So let ax square plus bx plus c be the quadratic polynomial, okay? And alpha and beta are the zeros. So we'll see sum and product. What is the sum? What is the sum? 0. So what is sum of zeros? It is minus of coefficient of x. What is the minus of coefficient of x? It is b. And coefficient of x square, it is a. So minus of b by a equals to 0. 0 by 1 you can say, which is same as 0. So now what is product of the zeros? It is root 5, which is constant term by the coefficient of x square, which is a, c by a, okay? So c by a equals to root 5 by 1 you can write, because root 5 by 1 is root 5. So here you don't need to do anything because the a is similar. So now you got a as 1, b 0 and c is root 5. This we will substitute here and we will get the quadratic polynomial. So the required quadratic polynomial is, you can substitute here. What is a? A is 1. You can write x square, no need to write 1. What is b? It is 0. So 0 into x is 0. So no need to write for b, you write the c. What is c? Is root 5. So the required quadratic polynomial is x square plus c for the zeros 0 and 5, okay? I have done here till question number 3. So you can do the other 3, 4, 5 and 6 by yourself. It is the same method here, and if you have problem with solving those 3, you can leave in the comment section below. I'll solve it for that. As of now, thank you and goodbye.